Okay, this is the bobbing magnesium experiment. What we've got here is some magnesium ribbon. We've cleaned up the surface to remove the surface oxide, and we need a piece that's about 1 centimetre or so long, so you can see about that, just roughly estimated, and cut that off with scissors there. Right, one's just gone somewhere, so we'll cut off another one. There we are. And onto that piece of magnesium, we're going to put some super glue, just a snail's trail of super glue there. That getting on our hands, hopefully. There we go. And onto that super glue, we're going to put some manganese dioxide. You'll see one in a second, so if we encourage that down onto the top there, come on. So you used before. We recycle this and use it as many times as we like. There. So, coated with manganese dioxide. And we need to quickly retrieve our piece of magnesium on from there. So it's in there somewhere. Come on, where have we gone? Oh, there it is. And we turn that upside down, give it a shake. As I said, we can reuse magnesium dioxide. And there's the magnesium that's been coated with magnesium dioxide with a super glue there. So we'll leave that to dry just over on the side there for a few seconds whilst we proceed with the remainder of the experiment. So we've got a standard 100 centimetres cubed measuring cylinder here, and into that we're going to put 20 centimetres cubed of this sucrose solution that's had 120 grams of sucrose dissolved in 120 mils or centimetres cubed of water. So into the bottom of the measuring cylinder, this is our most dense sucrose solution, so we're pouring 20 mils or thereabouts, we'll lay at the bottom. Now, we found to recover the magnesium rather, we can acidify that, so we're going to put in 1 mil or 2, just roughly approximate a couple of mils of 2 molar hydrochloric acid, give it a swirl, just to make it acidic in case the magnesium finds its way down there in the end. The next layer is to take 20 mils of, again, the most dense sugar solution, so that's 10 mils of this that we'll require, 10 mils of the most dense sugar solution, 120 grams of sucrose into 120 centimetres cubed of water. So 10 centimetres cubed of that, plus 10 centimetres cubed of this 620 volume rather, hydrogen peroxide, 6% hydrogen peroxide solution. So we'll add that. Again, another 10 centimetres cubed, which will take us to a total volume of 20, of course. So we've added that. We need to give that a quick mix, pouring it into this beaker of water here. This beaker, no water there. I'm confused, rushing. So that's a quick mix, the sugar solution and the hydrogen peroxide. And then use this layering tool, it's a cocktail layering tool, to introduce the, you see that I've inserted it into the top of the measuring cylinder, and that just helps the solution that we're going to add to run down the side. So I'll now pour this solution into the layering tool, and you'll watch it flow down the side. There it goes, forming a layer on top of the bottom layer there. Quite successful. We've got 2 layers. Right, the next layer that we want is actually a kind of a neutral layer. So we're going to take this second sucrose solution. This is made from 60 grams of sucrose in 120 centimetres cubed of water, and we'll take 10 of that. So there we go, into the measuring cylinder. And to that we're going to add 10 centimetres cubed of water. So here's the distilled water, 10. Again, bringing the total volume to 20, just around approximate. Again, we need to give that a mix by pouring into the beaker. And then once more into the layering cocktail device to make it run down the side. So there it goes. You should be able to see it down the side of the measuring cylinder. And that's our third layer. The fourth and final layer that we're going to use is 0.2 molar iron 3 chloride. So we'll use 20 centimetres cube of that. Let's introduce that into the measuring cylinder. Iron 3 chloride is of course acidic, and being an acid it will react with the magnesium. But we'll also get a displacement reaction occurring where the magnesium displaces the iron from solution, and hopefully the magnesium will be coated with the iron, making the magnesium more dense. Now, let's just add that to the layering device, the cocktail layer there, and you can see the iron 3 chloride running down. Now it is mixing with the second layer, but hopefully it isn't going down into the third layer there. So we have a layering effect. Just wait for the remainder of that to go down. Yeah, that's worked. Right, so we move that over to the sink. And finally we're ready. Now, we have a piece of magnesium which has got some manganese dioxide coated onto it. Now, if we put that into iron 3 chloride solution at the top here, it will fizz and react and produce hydrogen. But if we displace iron and coat the magnesium with iron, we hope to increase the density of the metal on the surface, and it should sink. If it sinks down into the third layer that contains the hydrogen peroxide, we're hoping the manganese dioxide on the surface will react with the hydrogen peroxide, producing oxygen. Again, oxygen bubbles on the surface of the metal should cause it to come back up, and thus we get an oscillating up and down piece of magnesium. That's the idea anyway. Let's see if it works in practice. So drop it in it goes. So it bobs a little at the start. I'm just going to turn it there so that you can see it at the surface of the measuring cylinder. Now you might be able to detect a little bit of fizzing going on. We expect that. And sometimes you do have to give this a nudge with a glass rod to get it to sink the first time, but once it gets going it's usually quite reliable. So I'm going to do that now. Here's the glass rod and just nudge the magnesium down. Of course it sinks. Just remaining at the surface at the moment, producing bubbles of hydrogen as we expect. Let's give it another nudge. Yeah, a little poke. Nothing yet. Let's rotate so you can see it a little bit more clearly. There it is. So it takes a minute or two to get started. Give it another nudge. There it goes, down. Rotate, it's back at the surface again. And just rotating now. You can see some of the manganese dioxide falling off, or maybe iron at the moment, so perhaps should leave that to do what it's going to do. And there you can start to see it just starting to duck and dive. There it goes. Back up to the surface. I want to get it on camera. Come on, round this side. There he goes, just starting to do the oscillation. Come on. There it goes, down and up. Come on. It's rotating there so you can see again. There, down and up.